pleasure to introduce Dr. R.A. Sengupta, Adjunct Professor, School of Petroleum Technology, Pandit Deendayal Petroleum University. Sir is PhD in 1993 from MS University and MTech and BTech from Nagpur University. Dr. Sengupta has 30 years of teaching experience at postgraduate level courses in production of petrochemicals, process modeling, simulation and control, petrochemical reaction engineering, transport processes, and process design and synthesis. Sir has 34 years of teaching undergraduate courses in mass transfer, transport phenomena, and process equipment design. Dr. Sengupta has research experience of 37 years, focused mainly on areas of fluidization, novel separation techniques, including foam separations and emulsion liquid membranes, along with nanoparticle synthesis and nanocomposites. Sir has guided 6 PhD students, including me, 45 plus ME research projects, published various papers in Scopus journals having impact factor from 1 to 6, published 2 book chapters in edited international volumes, and total citation 181. Sir has presented 40 plus papers in international and national conferences, reviewer of various international journals, delivered 3 keynote lectures in national seminars, and completed 3 major research projects having total outlay of rupees 34 lakhs. Sir is retired as professor from the Maharaja Sayajirao University of Baroda and worked as Director Internal Quality Assurance Cell, the MSU, member of Senate and Syndicate, MSU Baroda. There is much more to his credit. Without wasting much of time, I request Sir to please take the charge of session. Please, Sir. We are highly obliged with your presence, Sir, and very thankful for accepting our invitation. Thank you, Sir.
Thank you so much, Reshma, for an introduction which makes me feel as if I am as big as Mount Everest. Okay, but
Yes,
the fact is that if you spend 35 odd years in teaching, anybody and everybody would achieve what I have done. So that is nothing, something which is very great. But yes, I have had an opportunity to be associated with a large number of extremely talented young students. And it is with their association that I have picked up certain things. And I will try to convey to you some of my experiences. I will not be conveying to you much of knowledge because in this area I don't have much knowledge anyway to convey. But I will convey to you some of my experiences and what I have picked up from friends, students, and of course teachers who were very knowledgeable. So, ladies and gentlemen, let me get started. I have around 34 to 35 slides, and in this 34-35 slides, I think I'll push through in around 1 hour and 20 minutes, which is anyway a long time for anybody to get bored. But after that, if you have any queries, then I will try to answer your queries if I specifically know the answers. Okay, thank you so much. So let's get started. And of course, before I get started, let me thank GEC Bharuch, Government Engineering College Bharuch, its dynamic head of department, Mr. Vaghela, Dr. Vaghela now, yes, and Dr. Naina Tahilramani, who did some very, what I should say, challenging work in the area of foam separations, which is again in the domain of tertiary treatment of wastewaters. and she would have been more eligible than me to give a lecture because she has hands-on experience. I have only bookish experience. And I would like to thank the principal of GEC for also giving me an opportunity to be present amongst you all and share my thoughts and ideas. Thank you so much. So let's get started, friends. Well, are the slides visible?
Yes, sir.
Okay, very good. Well, friends, the title of the topic which was assigned to me, and the fact is this, that I did not respond for a very my friends, they actually assigned me a topic, and the topic was liquid waste treatment. But I made some last minute changes, and I thought that instead of talking on liquid waste treatment per se, because that's a huge area, so I chose an even bigger area, and that is on liquid waste management. Okay, I have had some experience on liquid waste management in the sense that I was appointed the director of a government company, that is Narmada Clean Technologies, which is again located near Bharuch in Ankleshwar. So, and that is the company which treats various wastes that are coming to its treatment plants from some industrial zones near the special economic zones which are built in Bharuch, and then again in Ankleshwar, Jhagadia and all those places. And finally we give it a treatment, and then we pump it some 40 kilometers down into the sea, and inside the sea we transport the waste another 10 kilometers. It is one of India's most outstanding companies, and I had the privilege of being associated with them for a period of 5 years. And in that 5 years, I learned a lot of things. And some of those things will get reflected in what I say here. Well, friends, before you embark on any research or any, what I should say, studies related to liquid or any waste, what you need to do is first you need to understand what a waste is and why it is a waste. Well, in the broadest sense, a waste definition is and classification is something like this: any material which is not needed by the owner, producer or processor is a waste. So by virtue of inviting me to this lecture, I must thank the organizers that they have not made me feel that I am a waste. I am still needed. Okay, so any material which is not needed by the owner, the producer or processor is classified as a waste, and or is called a waste, and classification is all listed over here. It can be domestic waste, factory waste, e-waste, waste from oil factory, construction waste, agricultural waste, food processing waste, biomedical waste, nuclear waste, and still more. The list is endless. And in fact, more than anything else, our civilization has produced wastes. Okay, I don't know why we are so fond of technology or technologies which go on producing wastes. And when you think about any treatment techniques, or when you think about handling the waste or manage the waste, the most important thing is that you need to really first classify the waste, what the waste is. So what you should do is that you should know. I gather that most of you will be pretty young people in the age group below. That's why you have a very long career in front of you, and I would suppose that you should pay some attention to the first part of the talk. You know, the second and third parts, they will be changing with time, but the first part is very important, and therefore in the first part I have dealt totally with standards. My talk is in three parts. The first part is about waste identification, and second part is about certain features of waste handling, and the third part is primarily on waste treatment. Okay, as I told you, the waste treatment aspects will be changing, and when it comes to waste handling, it is primarily that what type of strategies you are going to develop to handle the waste and things like that. That will also be changing, but the first part is important. I have titled it as Know Your Waste. So in these days, everywhere you have KYC, know your customer. Banks say know your customer. But what happens is they penalize the customer by asking all sorts of things that the customer will have to somehow fetch out and provide to them. Otherwise, you can't bank with a banking system. So, but when it comes to waste, there is no customer. You are yourself the treater, the customer, and society has created that waste, and what you have to do is that you have to identify and classify the waste. And we are lucky that we have open access for a lot of information in this regard, and for that we should thank the Environmental Protection Agency of United States, which gives us with lot of information. And there is so much of information that it becomes impossible for one to really comprehend all of it. But I'll tell you that that information is more fundamental and more required than the information that we get in books, because most of the books, they are highly inadequate so far as any practical aspects of handling waste is concerned. Okay, so let us get to it. So this is what is a waste? To this question, under Schedule 1, as you can see that this is now a statutory document which is opening. Under Schedule 1, Section 1.1 of Environmental Protection Act, it's a legal statement, you know, Act 1997, which will be called the Act. Waste is defined as any solid, liquid or gas or any combination of them. That means they can be individual or any combination of them. That is a surplus product or unwanted byproduct of an activity, whether the product or byproduct is of value or not. So whatever is unwanted, it may have a lot of value, but still it is a waste. Okay, so that means the concept of waste itself is temporal. You know, what is waste today may become something which is very precious tomorrow. So keeping that in mind, you have to always work with a very open mind. Okay, when waste, and you should try to see that perhaps in future some of these wastes can be utilized to get a lot of wealth out of it. Well, according to EPA, the following classes of wastes are used throughout the standards. So these are the wastes which has been classified by EPA, Environmental Protection Agency, and that is a special waste. Now, special, you'll find it out later. Liquid waste. Obviously, you have understood it, but I also thought like that. But later on, I come to realize that liquid waste, what EPA says and what I understand, it's not totally it is not totally overlapping the ideas. So liquid waste, as per EPA definitions, we'll see later. Then you have hazardous waste. Yes, most of the wastes that we deal in the chemical industry, they tend to become hazardous because they are health hazards. Okay, and if they are not treated properly, then they will lead to a lot of difficulties to individuals, to communities, and to society in general. Then there is restricted solid waste. Okay, restricted solid waste means which is coming out of some very particular activities. So those things are the wastes, restricted waste. I'll not elaborate much on either hazardous waste because you have a lecture on hazardous waste, but I'm just going to give you some preliminary information. And regarding the solid wastes also. So there is one general solid waste which is putrescible. Putrescible means something which will decay. And what decays? Like food items will decay. Agricultural products will decay. These are all decayable wastes, so they are putrescible. Okay, and most of them, when they decay, they will give a very malodor, and it will be putrid in smell. So that's how this word putrescible has come. Then there is general solid waste, which is non-putrescible, like take the case of glass bottles, take the case of extended polystyrene cups. Okay, take the case of various plastics. They won't decay, but they are categorized in general solid wastes. Okay. Now, when you want to handle these wastes, there is a methodology of which you should use to handle these wastes. And I'm telling it to you because this is the way I feel that we should actually go. Instead of the way I worked out in most of my career, that is whenever I got an opportunity to work, I took up a chemical engineering aspect of some treatment technique and used it for a particular specific, what I should say, stuff, or some particularly I worked with phenolics. So phenol, I did not even know what phenol is and what is its toxicity and things like that. Just very blindly used a technique to treat phenol. Well, no, that is not the technique. You have to go through a sequence of processes, and that is what I'm trying to tell you right now. So there are certain principles of step-by-step waste classification process. Okay, and we should be aware of it, and everything is available on the net. You will have to simply go to the Environmental Protection Agency website. There are what I should say thousands of pages of literature, very well segregated. You just download it and read. Some of these things I'm presenting over here. So what is the step-by-step waste classification process? Where practicable, safe and appropriate, it is desirable to separate a mixture containing different classes of waste before classifying them separately. Okay, that means, see, what happens is you go to any dumping yard and you will find that all sorts of things are there. Okay, particularly solid materials, all sorts of things will be there. So what we should do is that we should try to separate out the various components of the mixture before we classify them. For example, a good example is given over here, waste tires. Waste tires are special wastes. Asbestos is also a special waste. So suppose you have waste tires are mixed with batteries. Okay. Now, all these batteries, most of the batteries, at least the lead acid batteries, the lithium batteries and all other things they are all hazardous waste. So therefore, I am very apprehensive about electric vehicles and things like that. What will happen a couple of decades later? You will be generating so much of hazardous waste that handling those wastes, if you don't have the knowledge, the techniques and methods, then it will create a havoc. So it would be desirable to separate the wastes. So only the hazardous component is classified as hazardous waste. Okay, so we should not classify the waste tires also as hazardous waste. We should be segregating the components that we get from various dumping yards of waste and classify the hazardous material as hazardous, classify the special waste as special waste, and things like that. Then 2 or more classes of waste must not be mixed in order to reduce the concentration of chemical contaminants. Now, this is something which is not practical and not, what I should say, plausible also, or possible also, because we try to, in most of our industries, we find that we dilute a very concentrated waste using pure water or whatever is the water that is available to reduce the concentration of contaminants so that you bring it in the processing limit. So this is what is usually done. But environmental protection agencies say that no, you must not mix 2 classes of waste to reduce the concentration of chemical contaminants. Dilution of contaminants is not an acceptable waste management option. Okay, so theoretically, theoretically it's not, but I don't know how things are in US, but in India it happens day in and day out in each and every special economic zone, each and every place which is treating waste, and each and every company which is discharging waste. So this includes the addition of water to any waste prior to laboratory analysis of the for the purpose of waste classification. Okay, at least the last sentence is very clear that so far as classification is concerned, don't mix, don't dilute. After the classification is there, then you may dilute. But this is what happens over here, that only after the classification, when we see that we are not able to anyway come in the limits of environmental laws, then we go for dilution. Then we have, when classifying waste using chemical assessment, because ultimately you will have to make some chemical analysis. Okay, and so when you are classifying waste by chemical assessment, it is not appropriate to exclude sample results. Okay, by selectively choosing sample results to classify waste introduces bias and violates fundamental statistical principles. This is slightly difficult to understand. For example, suppose a waste has been chemically assessed in situ, that is in place, and the waste is excavated and chemically assessed as a stockpile. Then both in situ and stockpile analytical results must be used in classifying the waste. So you cannot really selectively, for instance, it's like taking an ore and taking the material out of it. Okay, you cannot really ignore the other stuff which is present in the ore by selectively analyzing only your desired targets. Okay, it is like that. Now, with these principles, there are certain rules of classification of waste. The steps of waste classification must be applied in order presented below. This is not my statement, this is statement of EPA. EPA says that knowing the principles, when you go for classification, the steps of waste classification must be applied in order presented below. Now let us see what is the order. Once a waste classification has been established under a particular step, do not go to the next step. Okay. Then for whether it is solid or this, or whether it will evaporate and there will be a gaseous stuff coming from it and things like that. No, you classify it as a liquid state waste only. If you have classified, make it non-hazardous. This is the practice which is usually followed in India, that we know that something is hazardous, but we'll try to always see that it is non-hazardous so that the treatment methodologies will be simpler, expenditure on treatment will be less, and things like that. Don't try to fool the society and the government. That is what this thing means, and it happens worldwide also. The only exception is where special waste is mixed with restricted solid or hazardous waste. In these circumstances, the waste must be classified as special waste and the restricted solid or hazardous waste and managed as both of those classifications. So if there is a mixture of waste, then you classify it as special waste as well as hazardous waste. And try to treat it in accordance with the requirements of both the classes. Otherwise, a mixed waste must be classified according to the highest waste class of waste. For example, you have a non-liquid waste containing 3 contaminants: asbestos, tires, and radioactive, or clinical, that is bio-waste. And only one of these contaminants is present at the concentration specified for hazardous waste. Well, the waste must be treated and classified and treated as hazardous waste, because hazardous waste is the highest order. Okay, you will give a lot of importance to hazardous waste. So in that case, don't try to bring down the level. Okay. So what happens is, if one of the contaminants is hazardous, you treat the whole of the waste as hazardous, and then look out for different treatment techniques. Let me tell you that in doing all these things, there is a cost component and there is also a legal component. Let me tell you one thing, that you have to be reasonably well versed with legal aspects, or you have to keep yourself aware with legal aspects if you are willing to take up any assignment in the environmental control, what I should say, sectors of either the government or private organizations. Let me tell you that almost every day or every week, when I was with Narmada Clean Technologies, we were served court notices because of certain things which we could not comply. The Supreme Court is extremely interested that India gets stable so far as its handling of what I should say wastes is concerned. And because of that, what happens is all these legal aspects, they really come in. But there is another point to it. See, because there are many companies, and I have interacted with many industrialists who have complained that for the last 20 years, they have not been allowed to increase their production by even 1 milligram. And they have opened companies in Africa and other places. But in India, in Gujarat, they are not allowed to even increase their production by 1 milligram because of certain government restrictions that no, it will hamper with what I should say, the environmental progress of the state, and it will lead to environmental degradation. These are certain things which are true. Both sides, there are two sides of the coin. One side is that yes, many businesses and many industrialists, they try to avoid their responsibilities for waste treatment, okay, by undermining the waste. And second thing is that the government is also extremely, what I should say, harsh on businesses and on all businesses which are generating some amount of waste. What we need to have is some path which is an intermediate path where all of us, the manufacturer, the government, they can come together and find a way. Okay, the growth of industries in Western Europe and America took place at a time when people did not even know what And what has happened is now that we are all aware of the impact, they are enforcing certain rules which are extremely difficult for us to, what I should say, deal with. And it is at this point that we find that we also pay a penalty for being an open democracy. Okay, so in an open democracy like ours, we have to follow, we do follow out of our own will all government norms, and our government follows all international norms to which it is a signatory. Apply to China. China goes being a dictatorship, being a closed environment, okay, not being a democracy. It goes on the easiest methods to produce chemicals, to produce goods, and that's why they are able to capitalize on international market. So these things are also aspects which we have to keep our eyes open. Okay, that how are we going to deal with these things? That is important. Anyway, let's move further. Okay, as I told you that there are certain wastes which are called as special waste. So is the waste special waste? Special waste is a class of waste with unique regulatory requirements. This regulatory requirement comes in. The potential impacts of special waste need to be managed to minimize the risk of harm to the environment and human health. So what are special wastes? Special wastes could be the clinical wastes, that is what we call as the waste which is coming from hospitals, waste, the bio wastes, as we say. So they have to be dealt with separately, and they can be extremely toxic. Then you have asbestos waste, which is one of the earliest special wastes. Then you have radioactive wastes, waste tires, and anything classified as special waste in the Environmental Act. Okay. So all these are special wastes. So whenever you deal with special waste, you have to look at the requirements not only for treating the waste but also for handling them, okay, for transporting them and things like that. So that is something which is important, and incidentally let me tell you, all these things are followed in our country, at least in our country. Then the step 2 is the waste a liquid waste? Now you'll say, what is so great about liquid waste? We can see and find out this is a liquid waste, but no, that is not the methodology of identifying a liquid. Any waste other than a special waste which has these 4 categories is called, classified as a liquid waste, because all that looks like a liquid is not a liquid. Okay, and does it have an angle of repose of less than 5 degrees above horizontal? That means if you give an angle of 5 degrees, will the waste start flowing? If it is so, then you can call it as a liquid waste. Okay, there are certain greases which will not flow. A liquid or a solid become difficult, so you can perhaps put some of them into a special waste category. Okay. Does it become free flowing at or below 60 degrees Celsius, or when it is transported? Well, if condition 1 is not followed but condition 2 is followed, then it is a liquid waste anyway. Is generally not capable of being lifted by a spade or a shovel. Then only you would call it as a liquid waste. And it is classified as liquid waste under Environmental Act. So these are the conditions which would classify a liquid as a liquid. Okay. There are other things also, that there is a paint filter, and in paint filter, I have not brought that picture, but in a paint filter, which is like a Buchner funnel, you know. Over there you put a filter and above it you put some of the waste. If it transports itself without vacuum to the lower chamber within a stipulated time, then you can call it as a liquid waste. If the waste meets the above, it is classified as liquid phase waste and no further assessment is required, as I told you earlier itself. Now let's go to the other things. So first thing is you have to ensure that for liquid wastewater treatment that whether it is really liquid or not, and these are the conditions. Okay. Then the third step is the waste pre-classified? Some commonly generated waste types have been pre-classified as hazardous waste, general solid waste, or general solid waste which is non-putrescible. So if it is pre-classified, work with that. Step 4. Does the waste have hazardous characteristics? Now, what is hazardous characteristic? It could involve explosives, gases, flammable solids, oxidizing agents, corrosive gases, and corrosive substances. Sorry, it should not be corrosive gases, but corrosive substances. Then it is a hazardous waste. And determining the waste classification using chemical assessment. So if you are particularly interested in knowing what type of waste or what type of materials are there in the waste, then you can make a specific contaminant concentration, SCC as they call it. And this is used mostly for heavy materials. Heavy metals. Tahilramani has worked with heavy metals. So over there, we have to go in for a chemical quantification and a specific contaminant concentration is assessed. Particularly, we don't treat it as a liquid waste. It is a liquid, but it contains heavy metals. So we will have to have that specific contaminant concentration. And there is another aspect also to it, which is known as TCLP, that is toxic characteristic leaching procedure. Toxicity characteristic leaching procedure that is particularly applied to the run of mines products, which is quite specific. We have not done anything on these lines, but we have certainly done on specific contaminant concentrations. So at this step 5, I would leave you and for a short while get into about, very briefly, I think I'll tell you about hazardous waste because I have a lecture on hazardous waste. So just about what are the hazardous industrial wastes. So well, the hazardous industrial wastes are coming from mining, non-anthropogenic chemical formations, fertilizer industries, battery waste, tanneries. Actually, it is these tanneries which have actually polluted the whole of Ganges. Okay, they are all hazardous waste. They contain so much of chromium in it, toxic to human beings, toxic to aquatic life, and toxic to everything. We haven't really been able to do much about it, except for sloganeering, perhaps. And we have perhaps as much as expected. Lead acid battery smelters, then chloralkali industries, metal refining, petrochemical industries, solvents, plastics, these are all hazardous waste. This is our domain. And as some chemical engineers have been saying, that the main contributor to hazardous wastes and to most of the wastes has been the chemical industry. Okay, I don't know how true it is because chemical industry has also contributed to many good things, but in a self-agonizing moment, this is what people thought. Well, friends, for a broad categorization of wastes, which we all know that waste would be industrial wastes and general wastes. Industrial wastes may be ordinary industrial wastes, that is non-hazardous in nature, and industrial waste subject to special control, that is special solids or hazardous substances or radioactive substances. These are all in the second category. Then you have general waste, which is categorized as waste from business activities and domestic wastes. Okay, we understand these things. And then also general waste subject to special control. Okay, general waste subject to special control would be the what I should say, clinical wastes, which we obtain from hospitals and things like that. They are all subject to special control, and one has to be very particular about that. Otherwise, they can become a source for epidemics. So this is the first part, which comes to an end over here, friends, about categorization of waste, how you fix up the category, and how you should actually, before doing anything else, you should know your waste. And this is something which should get incorporated in the environmental engineering syllabi, which is not there anywhere, at least in India. The next thing which we do is we need to fix up an hierarchy of treatment and a strategy for treatment. Well, this is something which we do know about, and let us look at it. Well, friends, waste hierarchy. What is waste hierarchy? Well, it's a tool used in evaluation of processes that protect the environment alongside resource and energy consumption to most favorable to least favorable actions. Once more, let me read out. Waste hierarchy is a tool used in the evaluation of processes that protect the environment alongside resource and energy consumption, alongside resource and energy consumption to most favorable to least favorable actions. Now, what should be the waste hierarchy? Well, let us see a better picture. Okay, not a better picture, but a cropped picture. Okay. See, this right at the top of the pyramid is prevention. So if you can prevent having a waste, that is the best possible thing. Now, can we really do it all the time? We can in some cases we just can't. Okay, so we all know that prevention is better than cure, and it is the most favored option. But how far it will be possible, that depends upon the innovativeness of the individuals who are involved in that activity. Then it comes to minimization. You can, if you don't prevent, if you are not able to prevent, at least you can think of minimization. Minimization can be done by technological alternatives, process alternatives, and things like that. But for that, you have to do a lot of experimentation, lot of reading, and you have to keep your mind open for innovative ideas. Then comes reuse and recycling. They actually go together. I don't know why reuse and recycling are kept separate. Well, you see, if you recycle something, then obviously it will be reused. And worldwide, particularly with metals, there is a lot of recycling and reuse. For instance, if you take copper will be almost 40% is recycled. Okay, and reused. And why go to copper? Look at gold. Okay, gold doesn't have much of industrial applications. At least we don't know much about it except for catalysts. But look at the household good, the ornaments that you have in the house. It is mostly recycled, you know, because somebody doesn't like the design. From one generation to another it passes, the design is not liked, so you change the design. And in that process, the person who makes the new design makes some amount of money also. That's a different story. But there is recycling and reuse, particularly with metals, heavy metals. And in industrial metals, yes, copper, zinc, even cadmium. When you are recycling, it's obvious that it will be reused. Then comes energy recovery and the least favored option being disposal. Okay, so we should think of possibilities before we finally bury down the, what I should say, the material for disposal. Okay. Inverted pyramid structures of waste hierarchy are listed over here. Same thing, what is shown over here. Here disposal takes the least favored option. Here also it is the least favored option. But the best thing is that if you can reduce, if you can reuse, if you can recycle, and if you can recover energy or the material, and then you dispose. In fact, this is an old waste hierarchy. The new waste hierarchy is this. That is avoid. Okay, and it agrees totally with this idea of prevention, minimization, and things like that. So you avoid. Okay, change the technology. Don't let the waste happen. Then, if you can't avoid, then reduce. Okay, then think of reusing, think of repairing, think of recycle, think of recovery. And see, these things are not exclusively only to some materials. This can be also to gadgets, this can be also to artifacts, this can be also to various other items. Okay, that's why the term repair is coming over here. Okay, and recover and then finally dispose. Okay, so it needs a change in the thought process. Okay, it's like, you know, we all use, I think these days, disposable pens, isn't it? Most of our pens are disposable pens. That is, when we write at all, we write with disposable pens. And what we do is, when it is used or when it is no longer using, we simply dump it, throw it, and things like that. But it is mostly made up of, you know, Rishma will be knowing better, but I think it is polystyrene based material or polypropylene based. It's very difficult to actually, if you incinerate it, it's okay, but it will give out a lot of toxic gases. But otherwise, it is very difficult to biodegrade them. So what do? Instead of that, why don't you go back? But nobody would like to fill ink pens. Okay, and moreover, it becomes very expensive. Ink pens these days are the domain of only the wealthy and affordable. Okay, because a good quality ink pen has become something like a prestige issue. Okay, and we try to see that which ink pen this star is using and things like that. So, but there is an utility to it. You know, you can avoid the waste, but to avoid it, you have to change your mindset. Okay, that is something which is very important. How many of us will be able to do it? I really don't know, but we should try to think on these lines. Then there is what we call as the zero waste hierarchy. Now, zero waste hierarchy is this. Okay. For the best use, you reduce and conserve materials. That is, you refuse, return, reduce toxics, design out waste, reduce consumption and packaging. Okay. Packaging has become a huge source of waste. You see, what happens is these days, all of us, and particularly after the pandemic, we tend to buy more and more from, uh, business houses like Amazon. And as it is, we buy from Amazon because there are good offers over there, variety is there, and things like that. I can only tell you about books, and you will find that all these books, they come wrapped up in a packet to protect it. Now, what do you do about that? That cardboard box, you tend to throw it. And in this way, huge amount of wastage takes place. Okay, either it will come in a cardboard box or it will come in a plastic box which will have blister packings around it, and you really don't know what to do about it, so you simply dump it, and all these things, they go to the dump yards. And particularly that cardboard, is coming out of, it's a produce of trees. Okay, that's, you have to sacrifice trees in order to get that type of hardboards. Okay, so we have to what you want to do. Then encourage cyclical use of incentives to stop waste. Okay, manufacture products for sustainability and take back. Okay, that is very good. If the manufacturers do like that, I have seen one thing in jeans, particularly jeans, Levi's, they write that don't throw them. You give it to somebody else who can use it. Okay, because a jean will last for decades these days. Okay, and what happens is that what do you do with it after 4 or 5 years? You waste hierarchy, which is, I don't know how true it is, and how possible it will be, but eventually we will have to move in that direction. And zero waste hierarchy doesn't always apply only to, what I should say, it applies to all forms of waste, including food waste. You go to a restaurant with few friends and you will find that you almost waste as much or at least 1/4 of what you have ordered. So how is it justified? It's not justified. And there are many stories which are in circulation of people having wasted food wastes. Food in Germany, it was shared by Ratan Tata, that and some lady in the restaurant called the police and they had to give an explanation. They said that food, the planet is deficit of food. You have the money to buy the food, but that doesn't give you the right to waste it. That's something which is very important. We have to keep these things in mind. Well, friends, now we come to the topic, wastewater treatment. Wastewater treatment, as I told you, will vary from generation to generation. So it has been my choice to take up one treatment technique which has survived for more than 100 years. Okay. As it is, the techniques are nearly the same, but still, we will see. Well, first thing is that we have the waste. How do you get the wastewater? Okay, what are the points of? Okay, there are point sources and there are non-point sources. Non-point sources are diffuse sources that is coming from, urban households. Okay, that will come from urban households. That is which will bring in the what I should say, the municipal wastes, as we call it, and there can be agricultural runoff. Okay, but there are certain point sources also, and the point sources, they are like when you are dumping toxins at some particular place, or industrial facilities, or sewage treatment plants, they will all deal with their water at some particular point. So therefore, they are all listed as point sources. Direct discharge into water will go, and there is indirect discharge will go through various what I should say, diffused sources that will lead to water pollution. This is a slide which we chemical engineers will be familiar with, and all engineers, biologists, everybody will be familiar with what are the contaminants of wastewater. Okay. In fact, our syllabus recommend starts from here, and everything above is not necessary. Okay. So therefore, while we know one aspect, which is a temporal aspect, we don't know the philosophy. Okay, that is something which we have to take care of. Well, contaminants are suspended solids, mostly domestic use, industrial wastes, erosion by flow. They are the sources of these suspended solids. What is the environmental significance? It can cause sludge deposits and anaerobic conditions in aquatic environment. Okay, so when you have suspended solids, it will create an aquatic anaerobic conditions in aquatic environment, prevent the decay of substances. Biodegradable organics. It is coming from domestic and industrial wastes, cause biological degradation, which may use up oxygen in receiving water and result in undesirable conditions. You have pathogens which are always present in domestic waste, and they would lead to communicable diseases. Nutrients is present in domestic and industrial water wastes, and while nutrients are necessary for growth, both in plants as well as humans and in all life forms, but excess of nutrients can lead to huge problems, and that is what are dealt with over here. Then you have refractory organics, which is usually coming in industrial waste. Refractory organics are substances like surfactants, pesticides, okay, surfactant, what we say, additives. So they are not easy to biodegrade. They are mostly what I should say heterocyclic compounds. Okay, difficult to degrade. Okay, that's why they are called refractory. And it may cause taste and odor problems. They may be carcinogenic, they may be toxic. So you have to deal with it separately, and you'll have to deal with it with quite some zest. And you'll have to find out the microorganisms which can handle it. Okay. Then you have heavy metals, which is product of industrial waste, mining, etc. They cannot be metabolized. There is no microorganism which will metabolize it, but therefore they tend to grow. And they tend to grow in the sense that once there is a source of heavy metal, that heavy metal will not be metabolized, hence it will start accumulating. There is a tendency of bioaccumulation. Okay, and they will become toxic and may interfere with effluent reuse. And you have various other dissolved inorganic substances and increases above level in water supply by domestic and industrial use. They may call scaling and things like that. It is difficult to handle them. And they could interfere with effluent reuse. This is what it is. So you can also classify industrial waste on the basis of toxic and non-toxic nature. What is toxic nature and what is non-toxic waste? Well, basically domestic sewage is non-toxic. Food processing is largely non-toxic. Meat processing is largely non-toxic. Sugar, brewery and distillery, though they are nuisance, but they are non-toxic. Textile and synthetic fibers, they are non-toxic. Pulp and paper industry and laundry, they are all non-toxic, but they are a nuisance in the sense that if you have lived somewhere near a pulp and paper mill, you will see that that whole place tends to be so odorous. There is so much of malodor over there, and that is because of the sulfurous gases exit the reactors or the vats from time to time. That is the reason for this. Well, toxic waste will come from coal processing, petroleum refining, petrochemicals, surfactants, synthetic organic polymers, pesticides, pharmaceuticals, fertilizers, metal finishing, and explosives, and some basic organic chemicals. These are all will lead to toxic wastes. Handling them is separate techniques. Dealing with them, you can see immense diversity. And diversity, there will be very large number of treatment techniques which we have to focus on from time to time and try to evolve the best possible separation techniques. Like I've listed over here some of them. You have unit operations. What are the unit operations, unit processes and systems? If you are dealing with suspended solids, well, you have sedimentation, screening and comminution, then filtration, flotation, chemical polymer addition, coagulation, land treatment systems. All of them will be used for suspended solids in different sequence. So that sequence you will have to optimize. Then you have biodegradable organics. Well, there can be activated sludge techniques, fixed film trickling filters, okay, lagoons, land treatment systems. There are various physicochemical systems. Okay, there are different techniques also. For instance, biodegradable organics. If you take phenol in it, which is a toxic organic, then there are so many separation techniques which are available, which have been used, including foam separation of phenols, which was not very successful anyway, or liquid emulsion membranes, which was very successful, but eventually we did not know what to do with the trapped phenol and things. Pathogens. Well, chlorination, hypochlorination, ozonation, these are all techniques, unit operations and unit processes which are used to deal with pathogens. We all know about it. Okay, and this is in municipal practice followed for last almost 150 years. Nutrients. In nutrients, you have major nutrients like nitrogen, phosphorus. Well, the techniques are ammonia stripping, ion exchange, to some extent chlorination, fixed film nitrification and denitrification, suspended growth nitrification and denitrification. Means they partly when you deal with nutrients, you partly deal with anaerobic conditions, and that's why the suspended growth techniques and things like that they come in. When you're dealing with phosphorus, another nutrient, well, you coagulate with lime, biological and chemical phosphorus removal, then metal salt addition, and land treatment systems. You see, I am specifically not mentioning much about land treatment systems because land treatment systems are best to be avoided because it completely that land becomes extremely difficult, you know. Okay. So there are many then alternatives which you will have to find out to rehabilitate that land once you damage it with various, what I should say, constituents that are semi-toxic. Then you have refractory organics, which you can use carbon adsorption or tertiary ozonation. Heavy metals, you can do precipitation, ion exchange, or foam separations. But you see everywhere there is land treatment system. Land treatment system means you just dump land. That is eventually what you identify a place and where you are dumping it. But then how are you going to rehabilitate that over the years? Because it will eventually find its way to subsurface water, and when it goes to surface water, it will pollute the subsurface water. And it is that subsurface water will eventually reach an aquifer, and from there, you know, in the bore wells, in the wells, and in course of years, it will reach the, what I should say, the rivers, and the entire water would get polluted. So one should try to avoid these things. Dissolved inorganic solids you can remove by ion exchange, reverse osmosis, electrodialysis. Okay. Expensive techniques, but definite techniques. So next I'll show you something on the treatment methodology. Well, treatment methodology, what you are seeing over here is something which has been in practice since almost 1912. I am taking that time frame just to tell you that that was the time when a very important suppression, very important treatment technique came into existence. We'll look about it later. So you have a sewer. A sewer over here is not necessarily which is handling sewage. A sewer means a channel through which waste is coming. It goes to the pre-treatment works, and pre-treatment would be perhaps to add lime or things like that to facilitate sedimentation. So you go for primary sedimentation. Okay, you separate the sediments, and then the water goes for biological treatment. Okay, and then after that biological treatment, then you go for final sedimentation, and there will be partly recycle of the what I should say, of the totally used up sludge into the system, so that there will never be any shortage of the microorganisms which are necessary for the process to continue. After final sedimentation, the liquid is taken for final effluent, which is the final effluent, and it becomes the receiving water, or sometimes if it has some components, then it can go for tertiary treatment if required. And then you have this sludge which tends to accumulate, and there will be large amount of sludge which will be there. So you will have to find out methods for sludge disposal. Now, let me tell you, one of the biggest problems which happens in most of major effluent treatment plants is that they accumulate in sludge. This sludge is what I should say, is like a gel, which binds with a lot of water. Technology to deal with the sludge. Sometimes you have to transport the sludge from one location to another, where you can put it on a landfill area or some location where, with the effect of heat, it will slowly dry out. But if you are centrifuging it, then that sludge can be burned. Unless you experience it yourself, friends, it will be difficult to really know. I am not talking much about these things because the next picture is more illustrative. Well, the techniques of sewage treatment and techniques of wastewater treatment have gone unchanged for long time, except for small changes at some locations. So you always have a primary treatment which involves screening, then initial sedimentation, initial collection of sludge. Then you have a secondary treatment, which is a biological treatment. Then again, secondary sedimentation. Okay, separate out the sludge. Okay, thicken the sludge. Disinfection. This is how water is treated, disinfectant, by sanitizing, by adding chlorination or UV, and let the effluent go. Okay, with these techniques. Now, if you look at this picture, look at it carefully and you will find that the treatment modes can be divided into three major steps. One is primary settling. It's a physical process in which coarse particulates are removed by plain settling. Okay. Then coagulation of fine particles. You will have to coax the fine particles to get coagulated. So you will have to perhaps add some coagulants. Waste is high, so it will bring down the pH and facilitate coagulation. Then you go for biological treatment, and this biological treatment is in practice for last 100 years plus. Biological treatment consists of several steps. Broadly, two categories of biological treatment. One is the biofilters and second is the activated sludge processes. Biofilters are also called trickling filters, and they also go by some commercial names, which is in these days something like a PVC. Means it's, if you look at it, it will look like what we say, a small cooling tower. Okay, not the larger ones, the smaller cooling towers, which there will be a lot of plates, mostly plastic plates, on which the microorganism grows. Okay, and the water which has to be treated, it will simply trickle through it. So therefore it call it as a trickling filter also. Okay, biofilters, they will be called as trickling filters, and there can be different shapes. It can simply be also like what I should say, pebbles around which a biofilm is growing and things like that. There can be many different dimensions to it. The second one, which is the activated sludge process, is what I should say, a process of great importance. We'll see about it. So you see, primary treatment is this, that you have raw water, you are screening the material, then you have a grid channel, then flow meters, take it to a primary classifier, the underflow goes for sludge treatment, effluent for secondary treatment. So here, whatever is the sludge which is obtained is mostly because of the coagulation or the coagulants that you have added, and not really truly. So this is how you work it. Treatment system. So you remove everything which is cause. Then comes the activated sludge process, or you can have trickling filters. Activated sludge process was introduced to accelerate sewage degradation by aeration of sewage. So that was the idea, that if you aerate sewage, then it will perhaps degrade more rapidly. And initial efforts were not very successful. Okay, but people were consistent. The idea was something which the engineers, they were all civil engineers, they had the idea that it work. And the success was obtained in 1912 in Britain by Fowler. So this gentleman, he reported the first success of aeration to accelerate the sewage degradation. Now the deposited solids resulting from complete oxidation of sewage was called as the activated sludge. So whatever is the solid that results from complete oxidation of sewage was called as activated sludge. That was the name which is given. And in absence of a better name, and in order to, what I should say, make the whole thing acceptable to the then society, if you just say sludge, then people would discard it. Activated sludge is, there is an element of recycling. The ASP, that is activated sludge process, is an oxygen-induced biological system. And in chemical engineering terminology, it is known as suspended growth reactors. Okay, suspended growth reactors, or sometimes suspended fluidized bed reactors or things like that, but primarily suspended growth reactors. It's an oxygen-induced biological system. Now, based on flow patterns and mixing characteristics, ASPs vary widely. They can be plug flow or completely mixed activated sludge process, which is known as CMAP, completely mixed activated sludge process. That can also be there. This is how it will look like. From primary treatment, the water comes. There is an element of sludge which is recycled, and the water and sludge are mixed in the aerator. And then it goes to a secondary clarifier where the sludge is separated and the effluent goes for further treatment. Okay, and part of the sludge is recycled to maintain the microbial, what I should say, requirements, and a larger part goes for further sludge treatment, that is dewatering and whatever it is, incineration, things like that. I will try to rush through my slides because already 1.5 hours have gone. So I'll just try to finish in another 10 minutes. So bear with me. Now, what is the role of aeration in activated sludge process? Well, it functions in 3 purposes. It provides sufficient oxygen for microorganisms for oxidation of organic materials. It keeps suspended solids in suspension in the liquid medium. And third, it provides intimate contact between the soluble food and the microorganisms. Nutrients are added, of course, and then nutrients is soluble. So between the nutrient and microorganism, it will means aeration. Aeration provides these three purposes. Okay. In addition to, of course, the mass transfer aspects of design, which we say that it will increase the KL and KG and things KL over here. Those things are segregated, but in general, these are the purposes which are satisfied. Transformations in biological waste treatments. The objectives of wastewater treatment plant is to remove soluble organic and inorganic materials from the feed stream. This is something which we are very clear about. In biological processes, soluble carbon components are transformed into insoluble soluble carbon, insoluble, and cellular mass, certain metabolite intermediates, and carbon dioxide, gaseous carbon dioxide. So this is how the carbon is transformed. The nitrogenous constituents, which are coming from what I should say, the nutrients. The nitrogenous constituents are incorporated into cellular proteins, okay, and nucleic acids, and oxidized to inorganic nitrates, and then to gaseous nitrogen. The sulfur reaches cellular proteins, and rest is oxidized into inorganic sulfate. The phosphorus gets fixed in nucleic acid and energy-rich ATP bonds. So how many things we have accounted for, gentlemen? We have accounted for carbon, we have accounted for nitrogen, we have accounted for sulfur, we have accounted for phosphorus. But when you want to quantify these things, you cannot quantify. There is only one quantification. And that's why that quantification these days is looked upon with lot of, what I should say, doubt. People are skeptical about it. And I am talking about the biological oxygen demand. Because BOD accounts for only the soluble carbon components. And BOD, what's the science behind BOD? Why did BOD come into existence? Why it is at 5-day BOD? Why the temperature is 20 degrees centigrade? Certainly, these are questions which have been unanswered, and I don't know whether you have found an answer for it or not, but I'll tell you what I learned about it. And remember that BOD has been in use for hundreds of years. People have been using it. We know that it's not, it is a measure used. How did 20 degrees centigrade come? Well, you know that first major activated surge process, this plant came up in London, okay, which is by the river Thames. And the average temperature of Thames River along the whole year is 20 degrees centigrade. That is why that 20 degrees centigrade has come in that assessment of BOD. Days, because 5 days was the time frame from the point of discharge of the waste in London in the Thames River to, it took 5 days of time for the river water to reach the ocean Atlantic. That means that the residence time of the waste, once it was discharged in the river and it moved along with the current, it took 5 days to reach the ocean end. 5 days to reach the ocean mouth, sorry. So that is how that 5 days came into account. Otherwise, there is no logic behind it. You don't know why do you do it for 5 days. You can do it for 3 days also. Why don't you do for 7 days? Well, this is it. These are the sciences. So you know that it's largely empirical. And because it is empirical, uh, it doesn't really fit into all situations. Anyway, but still it's a measure, and it's always good to have a measure than not having a measure. Well, these are some wastewater characteristics from petroleum refining. That is the area in which I have been working. So how could I leave it? Chemical oxygen demand is, of course, the oxygen required for total degradation. Biological oxygen demand is the oxygen required for degradation of carbonaceous material. And this is it. At different locations like a topping plant, cracking, petrochemical unit, lube processing unit, all these will be. Our people at NIRI, particularly Professor Sundaresan, who was the director of NIRI, and Professor Sivaraman, they did a lot of good job and they classified it. Nowhere else you will find this type of information. Anyway, ladies and gentlemen, let us proceed and let me try to complete the remaining slides as quickly as possible. So this is again about pesticides. As I told you that they are refractory chemicals, and because they are refractory chemicals, you can see what type of pesticides are there, they can be classified as target oriented, they can be classified by composition, organic or inorganic, natural or synthetic, and so on and so forth. Organohalogenated, organophosphorus, carbamate, and others. So much of diversity of chemicals, and each of them complex to handle. So handling a pesticide waste is very difficult. Okay, but we are able to do it. Not that we are not able to do it. Okay, then comes the microorganisms which are known to degrade toxic organic pollutants. You see, if we start with phenolic compounds, well, all those acrombacters, acinobacter, all these things are there. Candida tropicalis, all these microorganisms, they are listed out over here. Hydrocarbons, you have E. coli, Candida, they are all surfactants. And when you are dealing with any, that is why we should classify the waste, because once we classify the waste, then we can go for the specific organic, what I should say, specific microorganism which will degrade that waste. And we should not try to mix waste, because if we mix it, then what will happen? The effectiveness and the efficacy of the treatment will reduce. Similarly, we have cyanide degrading microorganisms. Okay, so you have bacteria and you have fungi also. Okay, bacteria are faster than fungi, but cyanides can also be degraded. Cyanides are being degraded, but as it goes, that you have to have that specific strain. When you have that specific strain, then you can go in for rapid degradation. So friends, just to recapitulate what we have been doing, this is the wastewater treatment and recycling technologies. So you have primary water treatment technologies, which is screening, filtration, centrifugation, and sometimes it leads to sedimentation and gravity separation, coagulation, flotation. Secondary is aerobic and anaerobic processes, mostly biological processes. I talked only about aerobic processes. I did not mention about anaerobic processes. Anaerobic processes will be associated with trickling, can be associated with trickling filters. Aerobic processes can also be associated with trickling filters. And then you have the tertiary wastewater treatment, where a host of chemical engineering separation techniques come into existence, like distillation, crystallization, solvent extraction, precipitation, oxidation, ion exchange, adsorption, reverse osmosis, electrodialysis. in the department where I worked, that is the Chemical Engineering Department of MS University of Baroda, we encountered using tertiary treatment technologies, particularly in solvent extraction, emulsion liquid membranes, foam fractionation, which is not listed over here, foam separations. We also got very good success and appreciation by using precipitation stripping techniques, wherein we could harness wealth from waste by using solvent extraction and precipitation technique. We treated brass waste, okay, brass effluent, which if it had been dumped into the waters would have polluted the waters for centuries, but we could treat it, and from that we could recover the copper and zinc separately and reuse it. Okay, but these days, friends, what happens is that most of the industries these days are not isolated. They are located in special economic zones. Special economic zones have got their own problems, because when you are in a chemical special economic zone, then there are different chemicals. They produce chemicals, different types of chemicals, and they have what I should say, each one of them has a different characteristic. So what happens is that we need to then address the waste treatment or effluent treatment in such a manner that, yeah, some sort of primary treatment is done by the companies, but then the effluent is taken out. And when it is taken out, the measure is the COD content. And then it comes to a common effluent treatment plant. And in the common effluent treatment plant of that special economic zone, a treatment is given, and lines which are shown over here. Okay. And what happens is that we try the COD content to as much as possible. After that, when you have a facility like Narmada Clean Technologies in Bharuch, then what happens is you take the effluent to the final effluent treatment plant, and over there you again do a final finishing operation and bring down the effluent CO2 to around 200 or 250. Okay, and then you push it to the sea. When you push it to the sea, you have to see it's with a lot of responsibility. You have to ensure that the seas don't get polluted, and it is put into the high seas, almost 10 kilometers downstream inside the sea. So there are certain norms over there, and those norms are regulated by the government of India, and which goes on changing, and the government of India is in accordance with the international agencies and to the treaties that we have signed. So, and they are subject to change from time to time. And this is how the journey takes place, right from what I should say, the water which is reaching our homes and our industries, to finally being returned back to the oceans and seas. Okay, so I think I took up a lot of time, 1 hour 40 minutes. I never thought that I'll be able to talk so long. Okay, thank you so much. Of course, there are many other experiences which I had, which I could not share. There was no occasion. But if you have any queries, then I'll be happy to answer. Thank you.
Session is open for discussion. Participants, if you want to discuss some topic, or if you want to ask. No question? I think we are at the end of the session. Thank you, sir. Thank you for being with us. Sir has very well explained initially, right from the beginning, what waste is, step-by-step classification of waste, rules for classification of waste, special waste. Very important is definition of liquid waste, sources of hazardous waste. Sir has very well classified the whole topic in 3 categories. First part, categorization of waste. Second part, strategy of treatment. And third is primary, secondary, tertiary treatment. Sir has very well explained all these techniques in a lucid way. Thank you, sir, for being with us. Thank you for accepting our invitation. Thank you, sir.
Thank you so much. So I think I
Vaghela,
can
sir.
take my
Yes, ma'am.